In this lesson, you'll learn some shortcuts or laws for dealing with multiplying and dividing numbers with exponents. And it's important that you understand why these shortcuts work by looking at the expanded form of the exponents or of the expression. Now keep in mind these only work when the base is the same. For example, if you have a number such as 5 squared multiplied by 5 to the power 4, you can see that the base is identical. And if we're going to take this into expanded form, could be written like this: 5 times 5, that's the same as 5 squared, and then multiplied by 5 times 5 times 5 times 5. And if you take a look at that, this part represents 5 squared. This part represents 5 to the power 4. But if we're going to write that back into exponent form, you can see that we've got 5 multiplied by itself 6 times, which would be the same as 5 to the 6th power. So the shortcut for multiplying is to take the exponents and just add them together, because you have 2 5's multiplied by themselves and you have 4 5's multiplied together. So the total is 6. So 5 squared times 5 to the 4th can be rewritten as 5 to the 6th. All we do is add the two exponents together. So another example of that might be 2 cubed times 2 to the 4th. And just before we do it, try to think to yourself what the final result might be. And I'm just going to do this in expanded form: 2 times 2 times 2 multiplied by 2 times 2 times 2 times 2. And you can see that we've got 3 here, we've got 4 here, for a total of 7. So this expression would be equivalent to 2 to the 3 plus 4, which is the same as 2 to the 7th. Now dividing is going to work much the same. If we have 5 cubed divided by 5 squared, if we put this into expanded, now by the way, this would be the equivalent of this: 5 cubed divided by 5 squared. So we could put that in expanded form as 5 times 5 times 5 divided by 5 times 5. Now when you look at this division, you know that these two numbers, 5 divided by 5, are going to equal 1. And these two numbers, 5 divided by 5, are also going to be equal to 1. So they kind of cancel each other out, because you're just going to be multiplying by 1, which has no effect on the product. So you're left with a number 5, and in this case it would be 5 over 1, which is equal to 5. Now if that's going to be written as a power, it would be written as 5 to the first power, or 5 to the power 1. So you can see that up here, instead of adding the two exponents together, we just subtracted them. So 5 to the third power divided by 5 to the second power is 5 to the 3 minus 2 power, which is 5 to the power of 1. And we'll just take a look at one more example of division. So if I have 10 to the 4th power divided by 10 squared, or 10 to the 2nd power, this could be written in expanded form as 10 times 10 times 10 times 10 divided by 10 times 10. And again, we can take a look and cancel out some of these, which would just be equal to 1. And you're left with 10 times 10, which is the same as 10 squared. So when we look at our original expression, 10 to the 4th divided by 10 to the 2nd, we can just go 10 to the 4th subtract 2, 10 squared. So the shortcut is, when you're dividing exponents with the same base, you can just subtract the exponents. Now when you have a power raised to a power, let's just take a look at that for a minute. So we've got 3 squared raised to the power 3. If we're going to put this in expanded form, what this really means is 3 times 3 times 3 times 3 times 3 times 3. So we've got 3 squared, which is the equivalent of this, 3 times 3, and we've got it 3 times. Now again, if we take a look at this expanded form, we can see we've got 1, 2, 3, 4, 5, 6 uh, factors of 3. So that would be the same as 3 to the 6th. So, and if you take a look up here, that would be like multiplying 2 times 3. So when you've got a factor or an exponent raised to an exponent, then you just multiply the exponents together. Similarly, when a power or a product is raised to a power, such as 2 times 5, the product of that squared, that would be the equivalent of, let's just factor that out, 2 times 5 times 2 times 5. Now, if you take a look at these two, this expression, and you know that in multiplying factors we can change the factors around. We could say this is 2 times 2 times 5, and it doesn't change the value of the expression. So this would be 2 squared times 5 squared. So when you have a product raised to a power, you can just factor that out by taking each of the factors of the product and raising it to the same power. Similarly, when you have a quotient, such as 4 divided by 3, raised to a power, that's going to be the same as 4 divided by 3 raised to a power, which would also be the equivalent of 4 thirds times 4 thirds. And you know that that would be the same as 4 times 4 divided by 3 times 3. So our original expression up here could also be expressed as 4 squared divided by 3 squared. Or it could be expressed as a fraction, 4 squared divided by 3 squared. So it's important to know the rules or laws that govern the exponents, the multiplication and division of exponents, but it's also important to know why those shortcuts exist and be able to do the problems in expanded form.